Dah.
Hello, we are from BERNOULLI Group. My name is Cahya.
My name is Dewi, Fitria, Ditianingsih. My name is Aysha, Fernanda.
My name is Muhammad Rijal Fath.
We are going to talk about derivative. So, let's just get into it.
Hello, my name is Cahya. Welcome to the BERNOULLI Group. Today I'm going to explain to you about the derivative. So what is a derivative? If I can put it to word, a derivative is a way to show the instantaneous rate of a change in a function. So first, I'm going to give you an example. This is a curve, and to find the derivative we need 2 points. So if this is an x, the point here will be x comma fx, and as you can see there's a distance here, so the point will be x plus h, and this point will be x plus h comma f x plus h. This is the second point. So how do we find the derivative or the rate of change, instantaneous rate of change? First we have to find the slope. Slope, I have to tell you about it. A slope is to show the average rate of a change in a function. As you can see in here, this slope is the constant one. This is always changing. See, changing. So we can't find the average rate of change, but we can find the instantaneous rate of change using limit h approaching to 0. H is the distance, so distance approaching to 0. So what does that mean? So it means that the distance will become smaller and smaller because this point will move down from the curve, from this point to this point, until it is on top of each other and making the distance into 0. That is the using limit. So how do we find the derivative or instantaneous rate of change? First, we use the slope. This is the in high school, if you remember, the the formula of a slope: y2 minus y1, x2 minus x1. The y2 is fx plus h, the y1 is minus fx, and so on. X plus h minus x is x2 minus x1, and it will become fx plus h minus fx over h. So I'm going to explain to you about the various formula of derivative. There is the x to the power n. The derivative is n times x to the power of n minus 1. So the n goes below and it will be decreased by 1. And there's the addition one, the u plus a derivative equals to u prime plus a prime. U minus a derivative equals to u prime minus a prime. This is the multiplication one. U times a derivative equals to u prime times a plus a prime times u. The division one, u over a derivative equals to u prime times a minus a prime times u over a square. The u and a is functions, and sine x derivative equals to cos x. Cos x derivative equals to minus sine x. Tan x derivative equals to sec square x. The cotangent derivative equals to minus cosec square x. The sec x derivative equals to sec tan x. The cosec derivative equals to minus cosec cotangent x.
So these are the important things for the derivatives of trigonometric functions. If you cannot remember this question, we can always use the basic trigonometric question to done the derivatives. For example, you want to search for the derivatives of cosecant of x. We know that cosecant of x is equal to 1 over sinus of x. So we can use the product rule to done it. So it will be like this. So it will be minus cos x over sinus squared of x, and we know that cosinus over sinus of x is equal to cotangent of x, and 1 over sinus of x is equal to cosecant x. Therefore, we can get the answer. Usually, to do the derivatives of trigonometric function, we use chain rule. So this is the example. We have this question. So we have to derive the sinus, then times the derivative of the inside function, which is 10x. It will be 10 plus the derivative of cosinus, then times the derivatives of the inside function. So we simplify it and we will get this. So for the other example, instead of powered 1, we move to the higher order. So we simplify the question, and then we need to use the product rule and chain rule. So to do this, we know that we need to derive the sinus of 3 of x squared times the cosinus of 5x powered 4 plus the sinus 3x squared times the derivative of the cos 5x powered 4. Then we simplify it. Then to derive the sinus of 3x powered 2, we need to times the inside function. Also, to derive the cosinus of 5x powered 4, don't forget to derive the inside function. So it will be like this. Simplify it again. So we will get this result. And from here, we can simplify it more. So that's all for the trigonometric derivatives.
So today I'm gonna explain you about the high-level trigonometric derivatives. One of the example is hx equal to cos x cubic, and how we can answer the derivative of hx. So the formula is derivative of hx is derivative of hx times the derivative of the x cubic. So we can calculate the x, as we know the x cubic is gx. So first we have to derive the hx. So the hx, as we know, is cos x cubic. So the derivative is mean sin x cubic. Okay, and about the gx, about the x cubics, there is a formula gx equal x, the n is 3. So the derivative of gx is n. We put the n into the in front of the x times the x, and n minus 1. So n is 3, x 3 minus 1, it's 2. So there is it. And so the answer is the derivative of hx is mean sin derivative of x times the derivative of gx, 3x squared. So this is the answer of the derivative of cos x cubic. So today I'm gonna explain you about the implicit derivative. As we know, usually the derivative only derivative 2x. So how about there is y and the derivative? So this is one of the example of there is y in the derivative. I want to derive 2x only, but there is y. So there is a formula, as we know, u times v equal, this is the derivative result, derivative of u times v plus u times derivative of v. So we can conclude that the x is u and the y is v. So first the derivative of u first. So the derivative of u is x, and the derivative is 1. And how about the y? The y is v, and the derivative is 1 dy per dx, because it's implicit. We only derivative is 2x. So how? This is the way y, there is dy per dx. So first is y 1 equal to 1. This is the n, so we put the 1 in front of y, and 1 minus 1 equals 0. So y 0 is 1 dy per dx, because we only derivate it to x. So this is the result. X times y, the derivative is 1. So as we know, the derivative of x is 1. 1 equals v is y, plus x times 1 times dy per dx. It's y plus x times dy per dx equals 0. So how about the derivative is dy per dx equal minus y per x.
Hi, my name is Dewi Ditianingsih, and I want to explain about related rates. So, rate is basically how something changes with respect to time. This is one of the example. So, if the x squared plus y squared is equal to 25, and the dx over dt, which means how fast the variable x is changing with respect to time, and find the dy over dt. dy over dt is how fast the variable y is changing with respect to time when the x is equal to 3. So in this case, we can use implicit differentiation like this. So everything is respect to time, and then we can find 2x times dx over dt plus 2y times dy over dt. And this is how to find the y. And because the y has two results, we can try two of them. And we can find this dy over dt of y is equal to 4. The positive 4 will be minus 21 over 4, and if the y is equal to minus 4, the dy over dt will be 21 over 4. So let's have another example. The question is, water is leaking out of an inverted conical tank at a rate of 7,500 centimeter cube per minute. The height of the tank is 8 meter and it has a diameter of 6 meter at the top. If the water level is falling at a rate of 15 centimeter per minute when the height of the water is 0.25 meters, so what is the rate at which water is flowing into the tank? So we can use dv over dt net equal to dv over dt when the water is flowing into the tank minus dv over dt when the water is flowing out of the tank. And then how to find the derivative from that? We use the volume of the cone. The volume of the cone is 1 over 3 times pi times the radius square times height. So to have the same variable, we can change the r into h. How? This is how. So we can use rational. H over d is equal to 8 over 6. So because and then we will have 8 times d is equal to 6h, and we can substitute the d to 2r, and then we will find r is equal to 3h over 8, and then we put this r into this volume, and we will find the volume as 1 over 3 times pi times 9 over 64 times h power 3. And then we differentiate it. So we will have the dv over dt net is equal to minus 4,142 centimeter cube per minute. After this, we put this into the previous formula because the question has told that the rate of the water that leaking out is 7,500 centimeter cube per minute. So we can put that in here, and we will find the dv over dt when the water is flowing into the tank as 3,358 centimeter cube per minute. So let's move on to linear approximation and differentials. Linear approximation. This is the linearization. We can use the equation of the slope like y minus y1 equal to slope times x minus x1, and you will find the linearization of x is equal to f of a plus f prime of a times x min a. So this is the example of the linearization of the function. So we could see that when we are asked to estimate the square of 37, we can use the linearization, and we will find the result is 6.0833. So this is the other example. Estimate the given number using a local linear approximation. When you are asked the cube root of 8.1, you can use the linearization too. So this is how to do it. And we will find the result. The cube root of 8.1 is 2.00833 and 3. So let's move on to differential. This is the first example of the differential. So when you are asked the differential of y is equal to x power 6 plus 7x squared plus 3x is because the differential of y is dy over dx, and then we can write this down like this. Dy is equal to 6x power 5 plus 14x plus 3, and all of that is multiplied by dx, because before this it was dy over dx, and then the dx is moved to the right side. So this is the second example. And you are asked the differential of y is equal to x squared ln x. You can use this formula. Y prime is equal to u prime times v plus v prime plus times u, and then we will find this one. So let's move on to the last example. The last example is we are asked of the differential of the volume of sphere. here, we can find it like the first one, and then we can use the multiply by d over dr, and it will have the same result. So that's it from this. Thank you.
This is the end of the video. Please like, subscribe, and share it.
And we hope you understand.
Thank you.
you.